Let's get right into it. Today, we're cracking one of the kitchen's most infamous cold cases, the case of the clumped cacio e pepe.
I mean, think about it. You've got pasta, pecorino romano cheese, and black pepper. That's it. It should be foolproof. But how many times have you ended up with a clumpy, oily mess instead of a creamy sauce? The big question we're unpacking here is, why? Why does this beautiful, simple dish fail so spectacularly?
Well, the first clue is actually in the nature of the problem itself. What we're looking at here is what a scientist would get really excited about, a highly reproducible failure.
And here's the thing. This failure is so consistent. It happens to home cooks, it happens in fancy restaurants. One minute your sauce looks perfect, and the next, bam, it just collapses into this grainy, separated disaster. You know, for years, the advice was always so vague, right? Oh, just lower the heat, or you gotta keep stirring. But the fact that it fails so predictably, well, that makes it the perfect mystery for science to solve.
And that is exactly what a group of researchers did. They decided it was time to stop guessing and start measuring. They basically turned the kitchen into a full-blown laboratory.
Yeah, they threw out all the old kitchen folklore and started treating this pasta dish like a serious experiment in, of all things, soft matter physics. They wanted to find the exact tipping point where it all goes wrong.
To do that, they took control of the three big variables that every cook struggles with. First, you've got temperature. They didn't just guess. They applied heat in precise, controlled stages. Second, concentration, which is all about the ratio of cheese to that magical, starchy pasta water. And third, shear, which is really just a fancy science word for the force and speed of your stirring. And for each one, they measured exactly what was happening to the sauce.
And all this careful work led them to a huge breakthrough. It turns out, it's all about crossing one critical threshold.
Now listen to this, because this is the key. The sauce doesn't just get a little bit worse over time. It's not a slow slide into clumpiness. Nope. It hits a very specific point, a threshold, and the whole thing just collapses, all at once. It's a sudden, catastrophic event.
In physics, this is called a phase transition. And you already know exactly what this is. Think about water turning to ice. The water doesn't get kind of frozen. You cool it down to a very specific threshold, 0 degrees Celsius or 32 Fahrenheit, and boom, it rapidly changes its entire physical state from a liquid to a solid. Believe it or not, your cacio e pepe sauce is doing the exact same thing.
So what's actually happening on a tiny, microscopic level? Well, when it works, you have what's called a stable emulsion. The starch from the pasta water wraps around all the tiny fat droplets from the cheese, almost like a little life jacket, keeping everything suspended and creamy. But when you cross that heat threshold, the proteins in the cheese freak out. They change shape, they clump together, and they squeeze out all the fat and water. That beautiful creamy emulsion you had, it's gone. The system has collapsed.
This whole discovery gives us a completely new framework for what's happening in that pan. We're not just cooking dinner, we are literally managing a phase transition.
And here's the real mind-bender. The clumping, it isn't a mistake. It's just physics. When the heat is too high, that clumpy, separated state is actually the more stable physical state for those ingredients. The system isn't failing. It's just doing exactly what the laws of physics are telling it to do.
So how do we use this to make perfect cacio e pepe every single time? Simple. We manage the variables so we never even get close to that threshold. First, create a strong emulsion base. Then, and this is the absolute game changer, take the pan completely off the heat. By doing that, you've dropped the temperature below that critical point. Then, and only then, do you add the pasta and the rest of your cheese and stir like crazy. See, you're not trying to fix a broken sauce, you're preventing the phase transition from ever happening.
But what's so cool about this is that it's not just a lesson about one pasta dish. We're talking about universal principles that are at work all over our kitchens.
This dance between temperature, concentration, and stirring, it's a fundamental force that decides the fate of so many things we cook. The lessons from cacio e pepe apply almost everywhere.
Just think about it for a second. A fondue that breaks, a grainy mac and cheese sauce, a hollandaise that splits, even getting your oat milk to not curdle in your hot coffee. Yep, it's all the same physics. These are all just phase transitions waiting to happen, ones that you now know how to control.
Which brings us to this really powerful idea that came out of the research. You know, we love to talk about cooking with feeling and passion, but at its absolute core, cooking is physics. It's a phase diagram, a scientific map that predicts exactly how your ingredients are going to behave.
So the next time something goes haywire in your kitchen, don't just get frustrated. Step back and ask yourself, what's the physics here? What are the variables? Where's the threshold? Because that culinary failure might just be a really fascinating physics problem that's waiting for you to solve.